This would be the second half of the homework solutions, and the problem we're working on now is number 16. And number 16 states, from the information provided, use cell notation to describe the following systems. So A is the following. In 1/2 cell, a solution of platinum nitrate forms platinum metal, while in the other half, copper metal goes into solution to form copper nitrate, with all the solute concentrations being 1 molar. Okay, the copper going to form copper nitrate is the oxidation side of this reaction, and it represents the anode, which is why I'm writing it first, even though it described the other first. And then the platinum ion gaining 2 electrons to form a platinum electrode is the reduction side and is the cathode. Now the notation here is you start with copper line, copper 2+, and then you put a little parentheses to show that it's 1 molar, and then that represents the division. This is the anode, or the oxidation side, and then platinum 2+, 1 molar, goes to form platinum. And so that is the answer right there. B describes it as follows. The cathode, they tell you this, consists of a gold electrode in a 0.55 molar solution of gold nitrate, and the anode is a magnesium electrode in a 0.75 molar solution of magnesium nitrate. So the anode is magnesium to magnesium ion plus 2 electrons. This is oxidation, and it's the anode. And then the cathode is the gold solution gaining 3 electrons and going to form gold. And this is the reduction side, or the cathode. Now, in order to balance this, you would have to multiply this top equation by 3 and the bottom by 2. So the overall reaction that's occurring looks like so, with 3 times magnesium plus 2 times gold ion goes to form 3 magnesium ions plus 2 gold molecules or atoms. However, that does not affect how you write this down. You still start with magnesium, line, magnesium 2+, and this I believe is 0.75 molar, double line, then gold 3+, 0.55 molar, line, then gold, like that. C. The third system is a silver electrode in 1 molar silver nitrate, and the other half cell is a copper electrode in 1 molar copper nitrate, and then they tell you that the copper side is the oxidized side. They have to tell you one of those things, or else you don't know how to do this. So that means that the copper is what is the anode part, and so you have to write it first. And then the silver, I believe it was silver. Yes, silver starts out as silver plus an electron, goes to form silver metal. And this is the reduction part in the cathode. And again, you would have to multiply this bottom equation by 2 for the overall equation to be balanced. And so you have Cu plus 2 silvers goes to form Cu2+ plus 2 silver atoms. And it would be written as such: Cu line Cu2+, 1 molar, double line, then Ag plus line Ag. Oh, and there's 1 molar here. And so that's number 16. Now this next problem, make sure you understand this because this could be on a quiz or test, because it's a favorite of mine to do these calculations. And this is number 22, states that they want us to calculate the standard cell potential for each reaction below. Note whether the reaction is spontaneous under standard conditions. So the first one is manganese, Mn solid, plus nickel 2 plus goes to form manganese 2 plus nickel solid. The half reactions here is manganese goes to form manganese 2 plus 2 electrons, and this is the anode. And it's important to designate which is the anode and which is the cathode because it affects your calculation. And then nickel 2 plus 2 electrons goes to form nickel, and this is the cathode. Now, when you look in the table of Appendix L, I believe, you can look up the E0 for each of these, and the E0 for this is minus 1.185, and the E0 for this is minus 0.257. Now, the reason it's important to designate cathode and anode is because E0 for a cell is equal to the E0 for the cathode minus the E0 for the anode. And so if we put the numbers in here, we have the cathode, which is minus 0.257 minus a minus 1.185. If you do the math here, you get positive 0.928 volts. And a positive E0 means a spontaneous reaction. So that's A. B, you have copper aqueous plus aluminum solid goes to form aluminum aqueous plus copper solid. So again, we need to write the anode first. The anode is aluminum, goes to form aluminum ions plus 3 electrons. That's the anode. And the copper plus 2 electrons goes to form copper. That's the cathode. Now, the fact that you have to multiply one of these by 2 and one of these by 3 has no impact on this calculation. In other words, you do not multiply the top number by 2 and this bottom number by 3. You basically ignore that with this calculation. Now, for aluminum, it's minus 1.662. And for copper, it's positive 0.34. So the E0 is going to equal the E for the cathode minus the E for the anode, which is equal to 0.34 minus a minus 1.662. So the overall calculation is 1.999, which is also spontaneous. The next one is sodium solid plus lithium nitrate goes to form sodium nitrate plus lithium solid. So sodium solid goes to form sodium ion, so it's the anode. And lithium ion goes to form lithium, so it's the cathode. And so lithium is minus 3.04, and sodium is minus 2.71. I'm getting these numbers from the appendix L in the back of the book. And so, again, E0 is going to equal E cathode, minus E0 anode, which is equal to, now the cathode is minus 3.04, minus a minus 2.71. And if you do the math on this one, you get minus 0.33. So it's not spontaneous. The last one is copper nitrate plus barium goes to form barium nitrate plus copper. So barium goes to form barium ions plus 2 electrons, and it's the anode. And we look at that up in the back of the book and we get minus 2.912. And then the other half is copper. Calcium, excuse me. Calcium goes to form calcium, and this is the cathode. And so the cathode here is minus 2.868. So E0, and I'm not going to write this down again, the cathode is minus 2.868 minus a minus 2.912. So the overall is positive 0.044. So it's spontaneous. The last problem is just like the ones we just did. It's pretty straightforward. It's number 24. Determine the cell reaction and standard cell potential for a cell made of a cathode half cell consisting of a silver electrode and 1 molar silver nitrate, and an anode half cell consisting of zinc electrode and a 1 molar zinc nitrate in standard conditions. Or it says, is the reaction spontaneous in standard conditions? Okay, so the anode, they tell you, is the zinc. Okay, so the zinc is going to form zinc ions. This is the oxidation side, so this is the anode. And then the other half is silver. So it's going to gain an electron and form a silver atom, and it's the cathode. Now it wants to know the overall reaction, so you have to multiply this bottom one by 2. So this is 2Ag plus zinc goes to form 2Ag atoms plus zinc ion. And then E0 is going to equal the E of the cathode plus or minus, excuse me, the E0 of the anode. And looking in the back of the book, the anode is minus 0.7618, and the cathode is 0.7996 plus. And so it's 0.7996 minus a minus 0.7618. So the overall is 1.5614 volts plus. So in standard conditions, this is spontaneous. So make sure you know how to do this kind of calculation, because something like this will be on quizzes and tests. So just make sure that as you go through these, if you have any questions about how to do this, contact me before you take the quiz.